Okay, in today's topic, we look at the rates, and the learning objective is to recognize that rate is the relationship between two set of quantities, and also to work with density and pressure. So these are the keywords we have. But before we undergo this, it's very important that students need to understand the work on speed. We have done speed before. You need to understand the work we did on speed. Okay, now let's look at the rate. We say that a rate is the ratio of two quantities with different units. Two quantities with different units. That's the ratio of two quantities. Now, if I have example of if I have 3 is to 27, these are what we call a ratio. You see that ratio has no unit, so these are what we call a ratio, which if I reduce this to the simplest form, divide this by 3, you have 1 is 2, divide this by 3, you have 9. So this is what we call what? A ratio. But when we assign a unit, a different unit inside, we now talk about what? Rate. Example, I may say that for example, $1 is to 9 dirham AED. So in this case now, I'm talking about what? A rate. That in every $1 we have 9 dirham. Or I can go to supermarket and I see a poster that they said that maybe 1 kilogram of potato is maybe I say 1 kilo of potato is 2 dirham. You see, now this gives us what? A rate. That means that if I want to buy 5 kilogram of that same potato, what am I expecting to pay is what? 5 times what? 2. That gives me what? That gives me 10 dirham. So this is a kind of what? A rate. So rate is the ratio of two quantities with different units. So we have to note this, that speed is distance over time, density is mass over volume, and pressure is force over area. So note this, we'll be using it in our consequence solving of this. Okay, now let's look at this question here. This question says that a car maker claims that the fuel consumption rate for a particular car is 10.6 liters per 100 kilometer. 10.6 liter per 100 kilometer. Okay, now let's practice that. It claims that its consumption is 10.6 liters per 100 kilometer. Okay, this is the rate. Now the question says, how much fuel will it use to travel 300 kilometer? So how much fuel, liter of fuel, will it take that will be proportional to 300 kilometer? I will solve this question in two ways. Okay, now first of all, we know that we put this in a fraction, the ratio of 10.6 liter to 100 kilometer. Put it in fraction, we have 10.6 liters over 100 kilometer. Okay, now it will be equal to, we don't know this liter, we don't know the liter, but this gives us what? 300 kilometer. Okay, now if I cross multiply here to find this, let me say this to be x, that gives me 300 times this, or divided by this. Okay, so we have this to be that my liter, which is x, simply gives me what? 10.6 liter multiply by, that's cross multiply is what I'm doing, multiply by 300 kilometer, or divided by what? 100 kilometer. Okay, now kilometer cancel kilometer, 20 cancel 20. We have this multiplied by this, so the liters we have should be 3 multiplied by what? 3 multiplied by 10.6. That gives us what? 31.8. So that gives us 31.8 liters. And that gives us the answer. Okay, now the B part is A part. The B part says, what is the fuel consumption in liters per 10 kilometer? Liters per 10 kilometer. What it means is the ratio of liters per 10 kilometer. Now let's look at it. We have liters, put it in fraction. Liters over 10 kilometer will be equal to this, will be equal to 10.6 liters over 100 kilometer. Okay, so if I cross multiply, we have this to be this multiplied by this, over this multiplied by this. So this gives me what? 10 kilometer multiplied by what? 10.6 liters, or divided by 100 kilometer multiplied by liters. You see that? Cross multiply. Okay, now liters go out with liters, fine. Kilometer go out with kilometer, fine. Okay, we have this to be, this cancel this, and we have 10.6 divided by 10. I hope you are following my long division. We have 10.6 divided by 10, and that gives us 1.06. 10.6 divided by 10, that should give me 1.06. So the answer to this question should be 1.06. No unit, because units have already been cancelled out. Okay, now the C part, the last one, says, how far can it travel on 100 liters of fuel? How far can it travel in 100 liters of fuel? That means we are looking for the kilometer. So we have this to be the fraction of this, gives us 10.6 liters over 100 kilometer will be equal to what? We have that to be 100 liters over how far can it travel? We don't know. So this gives us what? We have this to be 100 kilometer multiplied by 100 liters, or divided by 10.6 liters. Okay, so liters cancel liters, so we have this to be what? This will give us 100 multiplied by 100, whatever it gives you, divided by 10.6, and that gives you what? 943, a whole number, 943. So that one now gives you 943 kilometer. So that's how we solve the problem. Now let's look at the other question. In this case, we have that the density of copper is this. Calculate the volume of 40 grams of copper. Okay, now we note that density gives us what? from what we have before, that density gives us mass over volume. Don't need to forget this, that density is mass over volume. So the density of a copper is 9 km per cm cube. Calculate the volume of 40 grams of what? Of copper. Now we are asked to find the volume. For us to find the volume, we have that the volume will simply gives us what? Mass divided by what? Density. Cross multiply. Okay? So the mass we have is what? This is the mass. Calculate the volume of mass is what? 40 grams. And density is what? 9 grams per cm cube. Cm cube always volume. Okay, so this cancel this, and we have that to be 40 divided by 9. So that gives us what? That gives us what? 4. This is a recurring current, a recurring decimal. So we have that to be 4.44444. So this gives us a 4.44 cm cube. So this gives us our volume. The B part says what? Calculate the mass of 40 cm cube. Cm cube is volume. 40 cm cube of copper. We are asked to calculate the mass. We know that density gives us mass over volume. If we are asked to calculate the mass, we have cross multiply. So mass will be density multiplied by volume. In this case, our density is what? Is 9 grams per cm cube, and the volume is what? 40 cm cube. So cm cube will go out with cm cube, and we have 9 times 40. So 9 times 40 gives us 360. So we have that to be what? 360 grams. Okay. Now the last question says a piece of metal has a mass of this. A piece of metal has a mass of 75.1 grams and a volume of 9.4 cm cube. Okay, let me wipe off this and the volume of that. Okay, now we are asked to, can the metal be copper? Give a reason for your answer. We have to look for the density. If the density is up to 9, then it can be a copper. But if the density is below 9, it cannot be a copper. That's just the reason. Okay, now let's find out. The density we know is mass over volume. They have that the mass is 75.1 grams over the volume is 9.4 cm cube. So the density will be what? We have that to be 75.1 divided by 9.4. So that gives us what? We have that to be 7.9. That means 8. Approximately, it gives us what? 8. That gives us 8 grams per cm cube. So since it is 8 grams per cm cube, it's not up to 9 because the density of the copper is 9. Since it's not up to 9, it is not what? A metal. Thank you for listening. Bye.